know cooking uses math, but did you know that cooking and baking are examples of physics in your daily life? Let's say you're making pasta. First, you have to boil water. If you put a thermometer into a pot of water as it sits on a hot stove, the temperature steadily rises as heat transfers from the stove to the pot. This form of heat transfer is called conduction. After the heat reaches the water, a different type of heat transfer occurs. Warm water from the bottom of the pot rises and cools, while cold water sinks and is warmed, forming convection currents. Once the temperature of the water reaches nearly 100 degrees Celsius, the water begins to boil. However, the temperature of the water remains the same. Why? Because all energy is used in the phase change of the water as it changes from a liquid to a gas. This is called the latent heat of vaporization. To stop all water from escaping the pot, you put a lid on it. Now, it's time to add the pasta. When frozen pasta is placed in boiling water, the water and pasta change in temperature until they reach the same temperature. If you graph their temperatures, it would look something like this. The law of conservation of energy tells us that energy can never be created or destroyed, only transferred. As a result, any heat lost by the water is gained by the pasta. Now, you want some tomato sauce for your pasta. You could heat it on the stove, but if you're in a hurry, the microwave oven is definitely quicker. Chances are you have one, like over 90% of American households do. The actual microwaves in your microwave oven are located in a magnetron. It generates microwaves by bouncing electrons up and down in a space exposed to a strong magnetic field. This magnetic field causes the electrons to circle around and absorb energy until they are strong enough to become microwaves. The process requires close to a kilovolt, or 1,000 volts of energy. The microwaves released are bigger than you'd expect, with a wavelength of 4 inches and a frequency of around 2.45 gigahertz. The microwaves bounce off metal until they find the water in your food, which absorbs microwaves and heats up. Though the window of your microwave is glass, there are tiny wires on the screen for the waves to bounce off of. So don't worry, you really can watch your food cook. Finally, it's time for dessert. You might go for a piece of chocolate, for example. The reason most people love chocolate so much also pertains to physics. The melting point of chocolate is only a little lower than your body temperature. So, when you eat chocolate, it immediately starts to melt, spreading the taste evenly across your mouth. But if you're going to cook something, a cake can be relatively simple. First, preheat the oven. The air inside the oven is first heated by conduction, then circulated by convection due to the differences in the densities of hot and cold air. Rather than spray the pan for your cake, you might want to choose a non-stick pan. The reason they're not sticky? A chemical called polytetrafluoroethylene, which is so dense that nothing can bind to it. Once your cake is in the oven, it experiences heat transfer by conduction as heat flows from the air and metal sides of the oven into the cake. Infrared light waves also heat your cake and help it to bake. Now you've cooked a meal and hopefully learned something about how physics applies to your daily life.